In this lesson, we shall find the remainder after division. We are performing polynomial division. And so we will proceed to actually perform the polynomial division and determine the remainder after the division. And we begin as follows. Right, so in this particular case, we have a particular choice of a method, and we shall use what we call synthetic. We shall use a method we call synthetic division. Right, and so we're going to draw like this. And we also will draw exactly that way. Right, let us just draw this particular block here, like this. We actually, therefore, would put the numbers. So we have 3 minus 5 minus 7 and 20. Right, and so we continue with the polynomial division, and so we're going to let the divisor x squared is 2x plus 3. Because we drop here the 3 will also drop. We drop the 3, we put it here. We drop the minus 5, we put it here exactly. We take 2, when we multiply 2 by 3, we get a 6. We put it here. 3 by 3 gives us a 9, we put it there. We perform addition. If you add minus 5 and 6, or we say 6 minus 5, we get exactly plus 1. We have a 9 minus 7 gives us 2 exactly. We are done with the addition. We continue with the multiplication. 2 times 1 gives us a 2. 3 times 1 gives us 3 there. Okay. And after this, we add 2 and 2. We get a 4. 20 and 3 gives us a 23. All right. And so we drop here. And we put here this 23. We put the 23. We divide the board like this. And thus we are able to see that in particular this here is the remainder. Is the remainder. And so thus we can say 3x cubed minus 5x squared plus 20. X squared minus 2x minus 3. Right, if we divide this, we get the quotient, and this is the quotient, 2-term expression, because we divided x cubed by x squared. The result is an x. And so the x is of the form mx plus c, giving us a linear function. Yeah? So this is of the form mx plus c, which is the linear quotient. And therefore, it is 3x plus 1 plus the remainder, this one. Also, the remainder is a 2-term expression, making it linear, 4x plus 23, all divided by the divisor, x squared minus 2x minus 3. What is the remainder? What is the remainder? Right, we can see clearly that the remainder is this one here, which is exactly 4x plus 23. 4x plus 23. 4x plus 23. 4x plus 23. Right, and so this is the remainder, and therefore we're supposed to find the remainder after division, and this is the remainder after division, namely 4x plus 23. We continue with our practice. The next method we shall use is a method we call the box method of division. Right, the next method we shall use is the box method of division. We divide x cubed by x squared. Right, so what we're going to do is we actually can do this, yeah? If you divide x cubed by x squared, we get an x, and this this particular x is linear, it is of the form mx plus c, giving us a linear polynomial or a linear, yes, a linear polynomial expression. And therefore, what we then do here is we are able to do this. Yeah, so we do it like this. So what we do then, we divide the following. Right, so you're going to actually divide by x squared. We also divide by minus 2x. We also divide by negative 3. Right. And so if we do this division, we actually are able to see, therefore, that our table is going to actually, or our box, it's going to actually have 3 rows. It's going to have exactly 3 rows. Right. So if it has 3 rows, then what about the quotient? If you divide the x cubed by x squared, the quotient is going to actually become linear, and therefore it is going to have most certainly like 2 terms, and therefore we're going to actually do it this way. Right. Right. We continue. Okay. So now we actually obviously have that those particular columns, and we have here what we call the remainder block. And so we're going to draw horizontal lines like this. We're going to draw horizontal lines this way. And so now drawing the horizontal lines this way, I mean, there are a couple of things we shall take into account. We divide actually 3x cubed by x squared. We get a 3x. Multiply x squared by 3x, we get 3x cubed. Minus 2x times 3x gives us minus 6x squared. Minus 3 times 3x is minus 9x. The x squared. So we need to put a term here whose sum with this would give us minus 5, and therefore it is exactly x squared. We divide x squared by x squared, it gives us a 1. And therefore, if we have x squared by 1, we get x squared. We have minus 2x by 1, gives us exactly minus 2x. And we have minus 3 times 1, which is exactly still a minus 3 there. This produces, what it does is it produces some linear terms here, like minus 9x, minus 2x. And therefore, we must decide what term to put here so that the sum of the minus 9 and the minus 2x with the term here is going to give us minus 7x. So this is minus 9. Right. So now, yeah, this minus 9 and minus 2x will give us minus 11x. And so what do you put here? We can put a 4x. Okay, we put exactly a 4x. Right. And so if we put a 4x, because we know minus 9x minus 2x is minus 11 plus 4. Right, minus 11 plus 4 is minus 7. Right, next, we decide what number to put here so that the constant term is catered for. In this case, with a minus 3 as a constant, and therefore we can only put a 23 here, because 23 added with minus 3 would give us a 20. Thus, it means that whenever you have 3x cubed minus 5x squared minus 7x plus 20, all divided by the following, all divided by x squared minus 2x minus 3 gives us the quotient, right? The quotient is what sits at the top here, which is 3x plus 1. The remainder is 4x plus 23, all divided by x squared minus 2x minus 3. And therefore, the remainder is 4x plus 23. The remainder is 4x plus 23. The remainder is 4x plus 23. And so now we have used the box method to actually solve this particular problem here. And so now we have more methods in mathematics we can use to find the remainder, because the question said we actually are supposed to find the remainder here after division. And so now we have exactly the following, right? We have exactly the following. So we have exactly the following. Right, this time around, we shall use what we call the long division. Long division method. How do we use the long division method? So we just draw a simple radical. And we have the 3x cubed minus 5x squared minus 7x plus 20. Right, all divided by x squared minus 2x minus 3. So we divide 3x cubed by x squared, it gives us exactly a 3x. X squared times 3x gives us 3x cubed. Minus 2x times 3x gives us minus 6x squared. Minus 3 and 3x gives us minus 9x. Right. So if you deal with this, you get a 0. And this is 6x squared minus 5, which gives us exactly an x squared. And this is 9 minus 7 gives us exactly a 2x. And therefore, if we have the top 20 minus whatever, it's going to give us exactly a plus 20 there. So, but we need to make sure that what we do is we put these 3x in the right position. In this case, the 3x not be put above the linear terms, so we put it over there. Right, in other words, we divided 3x cubed by x squared, we got a 3x, and therefore we must put it there, above the linear terms. Okay, next, we divide this x squared by x squared, we get a 1, we put it here. X squared by 1 minus 2x minus 3. All right, so we have this 0, and x squared minus x squared is a 0. Right. Right. So x squared minus x squared is 0. And this 2x plus 2x gives us exactly 4x. 20 plus 3 gives us exactly a 23. And this here is the remainder at the bottom. It is the remainder. This one. On this one, obviously, the divisor and the numerator is the dividend. So we can say thus 3x cubed minus 5x squared minus 7x plus 20 all divided by x squared minus 2x minus 3. The quotient is what? Is at the top, so it's 3x plus 1. The remainder is 4x plus 23, all divided by the divisor, x squared minus 2x minus 3. Right. So in the end, then we're able to see that the remainder, right, the remainder is what? It's exactly this, which is 4x plus 23, and that is the remainder. And so we must thank you for joining us. It was awesome having this particular discussion. We have used 3 specific methods of interest. We have used what we call the long division method, also called the division algorithm. Right, but also we have used the box method as another method of division. We also use synthetic division, which is another method of division as well. And we thank you for joining us. It was awesome having looking at this particular question, which was said as part of the NBTs, right? National Benchmark Tests, right? So we thank you for your attention. Until next time, take care and goodbye to you. Thank you and goodbye.